Well, today we're building a small project using the Anchor Pseudocode Compiler. This is a language that is exactly like C. In fact, it is C. It's just missing some curly brackets and braces and one layer of parentheses. But that's it. This is C. And we're going to show you how to build a C project and to make a project with a shared library, with or without the shared library. And we can include the shared library and build it right into the executable, and that's called a static build. Or we can split it off, and then other programs can access the functions in it. This template is going to support 4 major build styles. We've got Linux versus Windows, and a static versus a shared build. The static build is all combined into one executable with no dependencies. Everything's rolled into one package. The shared build requires an external or a shared DLL file, or in Linux it would be .so. The shared library is linked to at runtime, and it can be loaded at runtime too, but we're not going to do that on this project. So it's static versus shared. Our targets are going to be let's see, dupe and libdupe, and that'll just print a word several times. So you'll be able to go dupe some word and then the number of times, and it'll repeat that word several times. Okay, that's the application. That'll be the optional library here. We're going to build libdupe DLL on Windows, and we'll build dupe exe on Windows. And we can start with a source code. Normally it would be dupe.c. That would become dupe.exe. And libdupe.c will become libdupe.dll on a normal project. But we're going to use our Pseudocode Compiler, which is the same thing, really. It's all C when it gets done with it. The ANCH files are compiled into C files, and then those are made into an exe. And same down here. And we have a make file that'll tell it how to do all that. And that'll be part of this project. And one more thing, and that is libdupe-h. That is a shared or a header file to tie it all together. Now the header file is included, or will be included, in both executable sources, and the header file contains some declarations for the functions that are available in the DLL, so that the programs can compile against the DLL without necessarily having the DLL present. That's the handy thing about header files. You can pretty much target your application for whatever shared libraries might be available. And if you have a function that you would like to share that you think might be useful for more than one program, then the handy thing to do is to create a shared library like this. We got one more target here, and that is dupetest.exe. And that'll depend on this DLL here. So this will be one target right here. We could move that up even. We'll call that target 2, and this will be target 1 here. This standalone versus this shared build here. Yep. We can show how this might be statically linked by drawing some lines here, like so, showing that diagram there. Got one monolithic and one shared installation. So you got two styles of build here and two different operating systems. So that's 4 configuration options, all controlled by one makefile. It's going to be fun. Let's start by creating our shared library, libdupe. If we put this at the top of the file, that'll tell it that I can run the file with Anchor. It'll automatically run it anyway. We can make that executable. Let's change this a bit here, and we'll just make this take a string argument. So we've got a string and a size and an error return. That's kind of the convention that X libraries use. So we've got to remind everyone to free the pointer upon return from this function. And we're going to need some temporary variables. Yeah. I is good. Got to get the length of the string. We've got a spare index to use. We're going to initialize the error return to null. And we should probably do some checking on the U pointer that we're getting, the string input here. Got empty string error. Going to limit n here, the number, to some exportable number that'll apps can query that and find out what max repeat is supported. We'll set that to 1,000 for now. Good, great. So if we've got an error, now we want to return here. Okay, now that we're done with our error checking, we want to make sure we want to get some memory to work with. We don't cast malloc when we're writing in C code. There's no need for that. We got n times length. So we got the length of u here, which is the word that's coming in. And we've got the length of that right here, len. So we got n, which is the number, the count here. It's the number of words times the length plus 1. That's how many, that's how long, how much memory we're going to need. Size of our string. Looks good. There's one problem with this, and that is that we should check the return value from malloc, because it can return null on rare occasions if we run out of memory, for example. So we could do it this way, and this is pretty common. And then just do some stuff here. Or we could wrap this in double parentheses, or single parentheses with the pseudocode compiler. Same deal. It's the same thing, really. Just including it on one line. It's a matter of style, that's all. So we've got the index to 0. These are our start conditions. We're going to set that t to the temporary memory location here, or the return location. Got some memory to play with. That's t now. So as long as I is less than the number of words, we're going to continue with this loop. And over here, okay. We can use this word, or we can use stp, stpn cby. And that takes the destination and a source and a number, so we can just go ahead and put that in there. Now, we've got to make sure that we terminate the end of the string, because all strings in C end with the null byte or octet. We don't really need a semicolon there because we're using the pseudocode compiler, but it doesn't matter. You can put one there or omit it and it'll figure it out. So if we don't get a good malloc here, we got to warn people or give an error out. We'll return an out of memory error. If that's the case, and return that should handle all our error functions and everything. We don't have any includes here though, and we know strlen, it's part of the let's see, yeah, it's the string library right there. You got to include string.h. So let's go ahead and do that. What else do we need? We got malloc here, and that uses stdlib.h. We've got, that's a string function there. We've got size t. I think that's standard def. That should do it for now. That's our function. That's our repeat function. Just takes a word and repeats it n times. Instead of u here, that's kind of confusing. Yeah, that's kind of bad programming practice. So we should probably call that word. That would be a much better word for word. We're going to replace that. Where else is it? I think that's it. Save the file. Now we can put our main function in here that has got an int argument for the argument count and a pointer to a string array here. That's a list of arguments that the program receives from the command line. Let's define some variables here. We need a spare string to hold the error return, and another one for the words, I guess. We use size t because that's the convention for sizes, because we could increase that later to beyond the size of int if we wanted to. We won't have to change anything. This tells it that we want to check to see if people supply enough arguments to this function, otherwise, or this program. Otherwise, we're going to put an error out there for description. Yeah. So we got the argument count, test. Now we need to get an int from the argument here. And that doesn't work because we have to convert that to string first using the ATOI function. That takes the initial portion of the string and converts it to an int. Yeah, it does a pretty good job. Doesn't return any errors or anything though. We'll just hope it works. It's got error checking. We're going to run our repeat function up here. We're going to test it. That's the first argument supplied to the program. That's going to be our word, repeat word, first argument, number of times, second argument up there. And error return here. That's going to give us our error, if any. Yep. So now we can check it. And that's how we do that. That's pretty simple. That just says if S is valid, then we're going to print it, and then free the pointer. We've got to remember to free it. Remember, we reminded ourselves up here, it must be freed. So we run free on that, and that'll release the memory, so we don't have a memory leak, corruption, or anything when that finishes. However, in the case there is an error, we want to do something else. Print the error return 1, and that's our program. And it gives us some usage information when we try to run it. And since we're running it as a script, we have to use this line up here, this command. And it prints 25 X's. Now if we double the number of X's here, it'll print 25 of those. So this is working pretty well. We can also, because we're using that kind of a thing, because of that, we can actually give it weird characters like this, and it'll print those too. It'll print Unicode, and it's actually a handy way to print those Unicode strings. What the heck is that? That's weird. I didn't notice that. Weird stuff. All right. I didn't explain this top part very well. This is very busy. It's running as a shell script. This executable C source code. This line here, this first one, tells the bash interpreter to ignore, or actually it tells the compiler to ignore this part. And now we're running the Anchor executable launcher with the run command, and we're going to run this source code. That's $0 is the name of this source file, and it's going to give it these arguments. We can pass other arguments to the Anchor runner, including libraries and library paths and C flags, even compiler flags and stuff. It's all valid. After it runs, we have to put this semicolon and exit here to exit out of the bash interpreter, or the shell, because we don't want the shell to go down and execute the rest of this C source code, because that would probably give us very poor results. And something else I wanted to explain here is this level of indirection we've got going on here. These two asterisks there. There's a pointer to char. What's up with that, huh? Well, see, ordinarily we would just have a pointer to char, but we're going to modify the pointer. And so we put a level of indirection on there. It just adds one more. See, we're assigning the pointer to this identifier here, which is the string itself. But this is actually a chunk of memory right there, that just happens to have that value in it. After this is compiled, that's data, and this is pointing to it. So we just take this part here, not that, but this part can be modified. You see, because of the way C treats variables passed to it, the arguments. You can't modify the arguments, but you can modify what the argument points to. That's where pointers come in handy. So we've got this level of indirection there. So we can modify that, and we can change it around, and it'll actually modify that portion of it. So we're modifying it. See, that's what we're modifying right there. And we're dealing with that. Anyway, I just thought I'd try to explain that. It's confusing, but that is not what's happening here, although it's similar. we can also access them by index that way. So in this case, it's being used as a multi-dimensional array, but in this case, it's just a level of indirection that we can use to assign things back out from the function. It's a way to return more than one value. Anyway, now that we're done making this into one file and it runs, now that that works, and we can do repeats, and everything is working. Let's test the let's see. We test the range here. -1 is out of range. 52, 52, that was out of range. So we can, everything appears to be working. Let's separate this out into our separate files that we talked about earlier. First we got to make the, well, this part here shared. We want to share this with the world, and we want them to be able to link to it dynamically. Then we would make our own shared library with it. Save a copy here. We'll call that dupe. Yeah. So yeah, we'll call that dupe. So we got libdupe and dupe, and we want one more file here. Save a copy. libdupe.h. Here we've got dupe, libdupe, and libdupe.h. And libdupe, we want to be that, but we also want to include libdupe.h in our libdupe. Yeah. Include, we've got to put quotes around it, because that's the way that's supposed to work. We also got to do that to this one here. So we'll go ahead and do that. libdupe.h will include this part here. Well, not that, but it will include this. So we'll go ahead and move that over to libdupe.h. And we don't need that in there. And we don't need anything below here in libdupe.h. And we should put parentheses around that, because this is C now in the header file. The header file is C. And we should put extern there, because it's a header. And that's just convention. Most C compilers automatically put that in for you. It's a ghost extern, but I don't know if it's tradition or what, but most header files have extern on the ones on the functions that they are exporting to other applications, and then they'll just leave it off the ones that are private, or yeah, or even declare them static within that private library. Yeah, they'll have their own static functions sometimes. All right, this is called dupe, and we can get rid of that because we're just using that part right there. Dupe, libdupe, and libdupe.h. Let's see if that's everything that we need here. We could This just tells it to ignore multiple defines, so we don't define that more than we need to. That's all we need for this file. Yeah, so a blank line there. So we got dupe. And we've got the include up there. That's what's included in there. And there. Now all we need is a makefile to explain how to build this stuff. So let's create that. Makefile. Now we'll just borrow this part here. We'll call this dupe. We've got C flags. These are normal compiler flags here. We're running a debug build, so we got the G and the wall options and the pedantic, and this here tells us that we're using C99 as our compiler or version, or I mean C version, yeah. Okay. Now to compile C files, this is the line I was talking about, to use Anchor to take those those Anch files and turn them into C code for us. That's the magic there. Now, if we need to get our C files, we need to turn them into object files. And that's what this does here. We're using our C flags, and we need includes. Now, to get our includes, we're going to put those up here. Those are the standard includes. Got USR include and the current directory right there. So that part should build. And this is all kind of boilerplate stuff here. What we're doing now, we could say, see, that's our compiler, CC. This allows people to change their compiler by changing the CC environment variable to point to their, compiler name. Okay, here we go with see, we can do it this way, where we just decide by the requirements, or we can do it some other way. So we build object files into .so files, if those are needed. Or we can do object files into DLL files. We could do it that way. I chose to do it a different way, and that was to make a lib variable. And that just tells whether to use one or the other. So it's just going to compile object files into whatever the type of lib that we want. That way we can define it up here. We can auto-detect it. And same down here, cc lib flags. macro for whatever comes in, and whatever goes out. That's the output there. So lib flags, output libs. We didn't specify those. One way to do that would be set up auto configure portion of this make file. Now you can do a separate configure program, but this makes it simpler. This is a pretty simple template, and we're just going to build our own make file and put the static libs and everything right in there. The static libs, that's going to be we're going to take all of our lib files basically, and that is lib.anch. And what we want to do with those is we want to path substitute .enc with .o on all of those. So that'll take the .enc extension and turn them all into .o for the ones that start with lib and end in anch. So basically that's just one file right now, the libdupe.anch, and we're going to build libdupe.o with that. That's for static libs. Static linking. We've got our static libs right there. How about that? Another thing we need is lib flags. And that is shared. And we could have another flag there to tell it that we're building a DLL. And the header file could use that if we were using a different compiler. But we don't need it right now. It doesn't really do anything right now. But you can use that for CDECL, CDECL, DLL import stuff. I'll put a link to that. I don't know. It's supposed to optimize the compilation, but it doesn't seem to work on MingW very well, and I think they might have optimized it out or something. It might be automatic now, or unnecessary. I can't seem to find any info on it. We've got the includes. We've got the lib being .so for Linux. But we wanted to test to see if we're on Windows. So we go, if not equal to nothing, find string mingw dot comma cc. That is basically if MingW is the compiler, or in the compiler string there, equals .exe, and lib is .dll. So we've got an ext now and a lib. Otherwise lib is .so, but if it's MingW, it's DLL. That just makes a decision based on whether we're using a MingW compiler or not. Now these are extra flags we can add for building a DLL on Linux. Yeah, because this is the Linux part here. And these are extra flags for position independent code. We add that to C flags on Linux. It's also optional. It gives you a warning if you don't put that in there, though. So we'll put that. And we need one more thing. And those are the little libs on the end of the compiler command when you're building, when you're linking against the dynamic libraries. And we just need to find those path subs again. lib.o. That becomes L%. So just L-lib. Static libs. That's our automatic configuration right there. That'll sort out whether we got libs or not, and where to put them. They'll be going down here. Lib flags. Yep. We need to build our exes too. That's the extension, optional. On Linux, it's nothing. It's nothing. On Windows, it's .exe. And if we if we need to build those, the makefile is told to build them from object files. Also. And with compiler. Using that output and LD flags and the L-libs we just defined there. So that's for building the exe, if necessary, linking to the library. Actually, you know, that isn't necessary right there. All right, let's duplicate that. We don't need that there. But in the case of a shared exe, which would be test exe, that also builds from an object file and includes the libs. So that's our dupe test exe target right there, with the extra libs, L-libs, options tagged onto the end there. All right, and now to make dupe, that's our first target. This is our default target. We could call it test, but that'd be confusing. So we're going to make dupe, but this is what you get when you just type make. Make automatically builds the first non% target that it finds, and that's going to be dupe. Name. These are the requirements, or the dependencies for dupe. It's going to use those, all the .o, the name.o, and the static libs. This is their static build, so that's our static libs. Compiler, static libs again. Name.exe, optional, LD flags. Those are the linker flags to build the library and link it right into the static executable. One big, huge file. Yeah, we want to change those into tabs too before we forget, but we'll do that. We'll remember. It'll warn us, or I mean, it'll error if we don't. Got a shared build. Again, we got name.o. And the same static libs as before. But we also want our dynamic DLL file. So we're going to tell it to build our DLL file in addition to the test file. So we're going to have to build the test and the DLL with this shared object shared target. Yeah. Again, path subs. You can take our object files. What we did there was just took those static libs, which are the no, not those. Yeah, those are .o files, and we just convert them into .dll files or .so, depending on what kind of magic tests we did up here. So yeah, that'll automatically build our static libs, name dash test extension. That's our shared target. And now we got a clean target. Yeah, clean thing. Remove name dot test ext name ext. That should be good for now. There's another thing we can do. If we want to keep the C object files around, the C files that are generated, we can make those secondary. So essentially, we're just telling it to keep all the C files around for later. We can comment that out if we want to. It'll erase the C files and just use the ANCH, the pseudocode files. We can compile pseudocode to C, and then it'll automatically delete the intermediate C files, and it'll look weird, but it'll work. Yeah, we can just continue development in pseudocode if we want. Just delete that or comment that line out and build pseudocode. We leave it in there or comment it out so that we can debug things later if we want. Sometimes it's handy to bring up the C file and see if there's any bugs in the Anchor translation happening. All right, we can try building with this makefile now. Oh yeah, that's right. The error. Forgot the error. We got to convert these to tabs. There. good. Puts. Implicit warning there. What file do we need for that? We need stdio.h. We need to put that in our header file. Somebody forgot to put stdio.h in there. Now what are we doing? Make clean and make it again. Implicit declaration of that. Let's see. stp ncpy. This one, yeah. There we go. Now the line will be correct. That one requires string H. I thought I included string H. Yeah. String H is included. Okay. I see what the problem is. Well, we're just gonna have to use good old string copy. It's not present. Should be, but it's not really there. And now we can get rid of this other cruft up here. Yeah, now it builds fine. Great. Let's try running it and testing our new file here. Undefined symbol repeat. Of course. Because we're running the we're trying to run against the dynamic version. We're not ready for that yet. There, we got dupe x25, and that's working. So the static version is compiled. Let's try making the shared version. Oh yeah. No rule to make dupe test. Right. That should be dupe test right there. Just a few typos in the makefile. Got a .o there, a .o there, and it's path subs, not path subs. Anyway, yeah, I cannot find L dupe. Yeah. Oh yeah, more typos. It's pat subs, and up here we got a percent sign there. It's supposed to be a dollar sign. Anyway, make shared. There we go. Finally, a lot of typos. I should have typed too quick. Anyway, that's working. We've got our build, our shared build, and our regular build. We can test our shared build now by running dupe.anch. And of course it's going to say undefined symbol. But we want to put these flags here into our run command. Yeah. There. Very well. That works because we're linking at runtime, and it's dynamically compiling and running and linking against the shared library at runtime and all that because it's there. We can go further and test the compilation steps on Windows. let's do that. Let's see here. How would we go about that? No, we're not in the right folder for that. There we are. We've got dupe test, dupe, libdupe, and all that. Let's clean this up and switch over to Windows building by going ww64.env. Yeah, there we go. Get that visible. We're building for Windows. We're in the Windows environment. Now we can go make. And that should build a exe. If everything went well. There it is. We can test that with wine. Usually takes a minute to start up. Yeah, it's working. Good. Let's see. Wine has trouble with those kinds of characters. Alright, let's see what we got now with shared build for Windows. So we've got libdupe.dll and dupetest.exe and dupe. You'll notice dupe test here is a little bit smaller than dupe. Now on bigger files it would make an even bigger difference, but we've got a little bit of space savings by using the DLL here. Not much, but like I said, with the big application, it could be some significant space saving if you put a lot of functions into a shared DLL and use them between your applications. Alright, let's try the shared version here. And that one's working too. Now we can take this libdupe DLL and delete it, or and try that again. And of course it'll fail because it's depending on that shared library. And there it is again, working. Alright, so that's how we build a template. Now hopefully whenever we want to have this make file, we can reuse it for other projects. The only thing we have to change is the name, and everything else is automatically determined for one library. I'm not sure how it would work for two. It might work, might need further debugging, I don't know, but for a simple template for a single file and a possible shared library or a monolithic static build, either way, 4 different options, one make file. It's not too bad. If you want anything more elegant, then use autoconf, automake. There'll be a link for that too in the description. Have fun with it. I just want to make a couple of quick changes here. I wanted to check for a maliciously long string. We'll give it a max word size or something. Max string. Something like that. Then we'll give an error. String too large error. We can define that in the header somewhere as 100. And let's see. Also, I would like to printf standard error. That'll send this out to the error terminal instead of standard in, which would be the normal terminal output. It'll still display in the terminal, but it won't concatenate into other scripts and stuff. That should probably do it right there. Let's compile that. Make shared. Something's wrong. Oh, I didn't put an equals sign in there. All right. Let's try that again. And test it. We want to put a very long string in here and see if we get an error there. String too large. So it's still printing the errors, but they're appearing in a different channel. And we'll be able to test that too by creating a file here. We could pipe that to a file. Let's see here. We could direct error channel 2 to a file named error. And we've suppressed the error output. We see exit code 1 here, which means there was an error, but we piped it to the error channel. Cat the error, which is a way to print what the file contents are, says out of range. So it's working. We've got an error channel and a standard output, and we've tested the length of the string and the repeats and stuff. It's repeating characters on demand. And here, that's working. Now if we cat the error again, we'll see nothing because there was no error this time. And that's how an error log works. Just did a little bit of logging. All right. Thanks for watching.